try to keep it fun and interactive. So like the third row, I want you guys to be the bike shedders, because I've never seen a successful software project that wasn't bike shedded, so it must not be a coincidence. If you see me writing any bugs or anything, feel free to shout it out. Any questions in the middle of it, you can shout that out also. Yeah, so hopefully this is working and fun. I am from the United States, but living in Amsterdam. I work for a company called Container Solutions. We're a cloud-native consultancy. Following the format from this morning, I don't work for AWS, at least not anymore. So I'm going to mention AWS a few times, but it's just to reference something that people are fairly familiar with. I'm technology agnostic, as is our consultancy. So my little project here is just for educational purposes. This isn't anything I want you to go download and use for production. Please don't try that. This is something that I've built. I've chosen the technology specifically for doing a talk live on stage. So I've chosen to build this in a particular way that makes the most sense when you code it up really quickly. So I'm calling it Scrappy Serverless. This idea came from JeffConf in London. I just was kind of boggled at how boggled people were about serverless. Maybe, I don't know, maybe it just makes sense to me. Maybe it's because I spent 4 years working at AWS, but to me, it's just the cloud. It's easy. You just automate the stuff that you do all the time. So I was hanging out in the yard of the church with Paul, and I said something along the lines of, this is easy. People don't understand it. You can just throw together a proof of concept. And being the person that he is, he said, yeah, so do it. So thank you, Paul. That's the reason I'm up here. In case you're wondering what scrappiness is, it's something that's sort of small and is determined to get the job done anyways, despite, by all appearances, not really being capable of doing so. So what we're going to build today is functions as a service, which means it's some web server that you can upload code to, and then just sort of auto-magically that code is available to make calls to. It manages its own infrastructure. You guys have heard people talking about this all day long, so I don't want to talk about what serverless is. Let's just get into building it. So first we're going to adjust some text sizes. I'm going to need people in the back to let me know when that looks right. All right. See if we can get these about the same size. And then an atom. Like that. Cool. And keep me in check. I like to edit text at the bottom of the screen, which apparently is really bad during presentations. So feel free to just shout at me if you can't really see the text I'm editing. All right. So what I have here is just a basic web server. For those of you that understand Python or Flask, you see that it's just a web server. It has a health URL and it has an index page. This is hello world for the web. Yeah. So this is just a web server. So we're going to try to turn it into something where we can submit code. I've got this this code here. I don't know if anybody has ever seen this program before. It's a very famous algorithm. But one thing that's really kind of incredible is this is so easy to write, but how long does this take to get up and running in production on an endpoint on the web, right? So just this hello world program, anybody that's in university for computer science can write it, but something like 0% of them are capable of getting it up and running on the internet. And I think that's really what serverless is all about. It's an extension of this CI/CD sort of movement that we've had over the last decade or so. It's a movement to take everything that you do after your code complete and get rid of it, make it go away, automate it, have some magical thing in the cloud do it for you. We want to just write the code, upload it somewhere, and it's running. Okay, so first we're going to add some function that just can accept this code and save it somewhere. There's going to be a lot of typos here. So this point should just take this code and save it in some sort of temporary place. I've got some kind of magical program running here that restarts this. And I also have Pylint running, so you're going to see that, per usual, Pylint is going to yell at me for a bunch of things that aren't actually a problem, but that's there to keep me in check while I'm up here on stage. So let's see if we can upload some code to that and get it to not return an error message. Okay, so that looks all right. So one of the core principles of serverless is that you have some kind of an automated build, which of course is a core principle of any kind of CI/CD methodology. So what we want to do is have the code get uploaded by the user, and then in this case, we're going to save it off as some sort of Docker image that we can go run the code in later on when we get some HTTP request for it. So we're going to work on some little recipe for Docker here to build that. Scrappy Serverless is the Docker image that I'm using just for this project in general. So in this case, we're going to be building the client image based on the server's image, which means that it will have all the dependencies we need for the project. So I'm using something called RQ here as a messaging subsystem between the different pieces of this. RQ is a Redis queue written in Python. You don't really need to understand more about it than it's just a messaging system. Okay, so we have some Docker recipe that takes this code, theoretically packages it up into an image, builds it, and then we capture the output from Docker. So let's try that. Let's see if the image builds and what the output looks like. Hold on just a second. I also forgot to do the import, so that seems important. Thank you for that. Import subprocess, okay. Pylint's happy. Okay, so we have a Docker image built now, and we've called it serverless/hello, which corresponds to the URL that we passed in, localhost. Oh, it's gone off the screen there now. That's good. /API/hello. So that was the command that I ran. I just brought it up on the bottom. So what we need to do now is capture this this image ID, because we're going to need to run it later on. So we need to know which Docker image corresponds to this particular piece of code that's been uploaded. So now we're just going to create some variable for that. And of course, we need to capture the image ID from the output also. And there's this particular line we're interested in. So I'm taking the last piece here. see if that builds okay. My code's rated at 10 out of 10. That means it's great, right? Guaranteed to work. Signed by Milan. Okay, so we got a response here, okay, 8.5, something or another. That should correspond with some Docker image on my system. And thanks to a missing new line, it likes to also mix with my prompt. There we go. Okay, so we have a 165 meg image now, which should contain that code. We can find out. So we see that we start off in the /worker directory. We have a handler.py file, which is good. That's our hello world algorithm. So it looks like we have an image up and running now, well, not up and running, but available, that contains the code we want to run. So let's see if we can launch that image now when we get some HTTP request. So we've completed this particular step. We'll have to wait to the next step to see how valid that image is. But it looks right, at least so far, from the inspection we've done. And the next step will be something like this. So we'll want to receive a call from some user, and then in response to that, pull the image and actually bring up some infrastructure that corresponds with that code which was uploaded before. And then after that, we will be trying to route the call actually into the particular image, into the particular infrastructure that corresponds to that image. So going back to the code now, we need a new method. Okay, so we're going to need to, first of all, bring up a queue from our queue, so we can send a message into that image, telling it about the work that we want to have done. So in this case, I'm just calling the queue name is going to be the same as the function name that we're calling. So if this was actually some production service, you know, there would be multiple workers out there responding to it. I think that might be the hardest word in the English language to spell, at least as a developer. 'And I'm missing an argument. I need to make sure that it's running on the particular network here. So I'm using Docker Compose. Docker Compose sets up a network for the application. Okay, that looks right as far as I can tell. Let's see what Milan thinks. Import should be placed at the top. Oh. Per usual, Milan is very helpful. Ten out of 10, this is definitely going to work. Guaranteed. Okay, so we have to upload the code again because the images dictionary is just in memory. We're not actually using Redis to store that data. So let's see what happens when we try to actually call this. Okay, so we got the response back. And we can see in Weave scope here that we have the serverless container, which is the web server. We have Redis running, and then we have these other containers that have executed. So serverless/hello had this one instance. 27 seconds ago, it exited 0. So the command was rq worker blah blah blah. The important bit is that the image was created automatically, and then it was brought up, and it died immediately after it did the work. So that's one of the things that's really core to serverless, and you've heard people talking about this all day, is that the infrastructure is super temporary. This is not, this is nothing really like what we've been used to before. It sort of forces the paradigm on the user of what we thought containers were going to be, right? So containers were meant to be this thing where it's very temporary. You don't rely on any sort of state and memory or on the machine, but some people, for instance, have determined that Lambda sometimes keeps you running on the same machine and things like that. Or just even if people aren't trying to do serverless, if they're just trying to sort of do the cloud, they'll make a container, but it's got all of these daemons and things in it. So one thing that serverless is doing in this case is it's forcing sort of a proper containerized paradigm in that you just have just some little bit of code. There's no SSH daemon running. There's no real disks to speak of. There's no state that you can store inside of that container. And so this works, but it's not terribly interesting because we can't pass any arguments into the function, and most real-world functions accept arguments. So we need some sort of way to do that. One thing that serverless is sort of doing is it's making the old C calling convention not necessarily so relevant, and we come up with new calling conventions. So the calling convention that's often used is just using these normal HTTP methods that people are used to. So let's try to pass something through the query string as an argument to that. We'll need to modify the example. Okay, so that looks right. So now we've modified the function just ever so slightly. Now it's made to accept some kind of parameter. We should be able to just run this currently, and it'll say hello user. Let's give that a shot. Dig way back into the command history. Okay, so we executed the function. It took the default of user because we weren't able to pass anything to it. But we passed the Jeff argument, and it's not really doing anything. And that's because the serverless infrastructure in this case isn't really handled to, it's not designed yet to pass that forward. So let's see if we can pass that in. Okay, that looks right. Can't tell if that actually restarted when I saved it. So we'll upload the code again and call it with an argument. All right. So now it's returning that value. In this case, I'm using Python repr. Usually the responses come back from these functions in JSON. That's really a minor detail in this case. So now we can see that we've submitted code from the user. We've built some Docker images automatically based on that code. In response to some HTTP calls, we've brought up infrastructure automatically using Docker run based on those images. And then using RQ, we're able to map the result that comes out of that code back to the user. Does that make sense? Does everybody have any questions about that process? So some interesting points here are possibly the ways that this isn't serverless. So obviously this is just essentially some container orchestration running on my laptop. So for one, it's not scalable. For two, you don't have support for intercalling between the different functions. So if I was to upload a second function to this, there's not really a convenient way to access that first hello world function that I had written. So most serverless infrastructure would have some sort of sensible way to easily call between the different functions that you've uploaded. Also, the reliability, so it's just running on my laptop, you're going to want a serverless provider that will automatically not only scale it out, but also distribute it geographically. Perhaps this could be architected so that it had like a CDN in front of it, and it was geographically distributed around the world as your calls changed. Plus the fact that it sucks and I wrote it on stage, so that's another reason you wouldn't want to use it. But if you are interested in viewing the code, I'm going to push it to here. That project currently exists, but there's not really anything interesting in it at the moment, but in like 10 minutes, there will be. So thank you. This is Scrappy Serverless.